Hi everyone, today we'll be looking at a very important concept in organic chemistry called formal charge. Have you ever wondered how chemists can look at a structure on a paper and predict which part of the molecule is going to react? The secret weapon is called formal charge. Think of it as a map, formal charge as a map, and it tells us where the electron stress points are. It tells us where electrons are concentrated, where they're itching to react, and also where they are missing. And that's what we're going to cover in this video today, formal charge. Let's take a quick example and let's look at CO2. CO2's Lewis structure could be potentially drawn out as, here is CO2. CO2 can be drawn as option 1, carbon is connected to oxygen with a double bond. So 2 oxygen and 1 carbon in the middle. Filling out the electrons because this oxygen over here only has 4 electrons. We need to fill out another 4 electrons to complete 8 total to complete its octet. So it's going to require 2 electrons here. 1, 2, 3, 4, 5, 6, 7, 8. Same thing over here. 1, 2, 3, 4. Let's fill in our electrons. 5, 6, 7, 8. So option 1 could be written out like this. Option 2, let's again take carbon. It is bonded with an oxygen, and it is also triple bonded with another oxygen. Let's fill out its octet. So 1, 2, 3, 4, 5, 6, 7, 8. Let's go ahead and fill out its electrons. 1, 2, 3, 4, 5, 6, 7, 8. Let's do the same for the opposite side now that it's triply bonded. 1, 2, 3, 4, 5, 6, 7, 8. Now, how do we differentiate between which one is the correct charge that chemists would typically associate for this compound? The way to figure this out is through formal charge, which would tell us overall if there is stability. So let's go ahead and take a look at the formula, and we'll come back to this. But I just wanted to show you between these two different forms of carbon dioxide, which one is the most stable. Okay. Let's fill out the formal charge formula. Usually online you would see formal charge is equal to valence electrons minus, actually, you know what, I'm going to run out some room. So let me go ahead and do this like this. So formal charge minus non-bonding electrons. I'm just going to abbreviate electrons like that. I hope you guys don't mind. Plus half bonding electrons. When I was studying formal charges, this made no sense to me. But a better way, I would have to say, to calculate formal charge is valence electrons minus the number of bonds you see, so the number of sticks, minus the dots. Each non-bonding electrons, which would be known as the dots. Okay, let's go ahead. Now with this great formula, I'm going to highlight it so you guys understand. Let's take our CO2 and let's calculate its formal charge. CO2, example 1. Let's go ahead and copy this actually so we can see it very clearly. Okay, CO2. Option 1, if you recall, it was carbon double bonded to 2 oxygen on either side. And to complete its octet for oxygen, it had 1, 2, 3, 4, 5, 6, 7, 8. Okay, it had 2 sets of lone pairs. So let's double check and count to make sure that oxygen has a complete octet. 1, 2, 3, 4, 5, 6, 7, 8. Carbon double bonded and double bonded on the other side. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. So pretty much this oxygen has a complete octet and this oxygen has a complete octet. Let's double check for carbon. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So this works. Let's calculate its formal charge. So as we said, formal charge is equal to the number of valence electrons. So we'll take each one and calculate its formal charge on each atom. Let's go ahead and start with, let's label this as oxygen 1 and oxygen 2 and just simply carbon since there's only one carbon. I'll highlight those and let's calculate each of its formal charge. So let's begin with oxygen 1. Oxygen 1, you know what, let me actually color code the oxygen so we can tell. It'll be easier for us to understand. So oxygen 1, let's take a look at this formula back up here and let's plug it all in. Valence electrons, so oxygen 1 over here has 6 valence electrons. And how do I know that? If you look at the periodic table, and if you look at the columns of each one of them, oxygen follows oxygen follows underneath the 6A category. And so that's how I know that oxygen has 6 valence electrons. So oxygen 1 has 6 valence electrons minus the number of bonds. So if we look up here, the number of bonds. And if I look at it, I see that oxygen has 2 bonds. So bond number 1 and bond number 2. So it has 2 bonds minus each dot, otherwise known as non-bonding electrons. So these electrons are not bonded in a bond, while for these electrons are bonded in a bond over here. So let's count each dot. 1, 2, 3, 4. That's 4 non-bonding electrons. Let's double check because we want to make sure we make no mistakes. So oxygen has 6 valence electrons, and we can tell from the periodic table looking at the column underneath 6A. 6 minus 2, because there are 2 bonds or 2 sticks, minus 4 electrons. 1, 2, 3, 4. That gives us a total of 0. So the formal charge on oxygen is completely 0. Let's go ahead and take a look at carbon. Carbon has 4 valence electrons, and we can tell from the periodic table how it falls underneath group 4A, minus how many sticks do we see? Well, if we count the number of sticks, 1, 2, 3, 4. There are 4 sticks. Minus, and because it's a complete octet, there aren't any dots on it. Minus 0 gives me a formal charge of 0. Wow. Okay, let's take a look at oxygen 2. The same thing. Even though they're identical on either side, I'm still going to calculate it just to make sure and just so you guys can visualize it. Oh, I made that pink. Oxygen follows underneath category 6A on the periodic table, so I know it has 6 valence electrons, minus it has 2 bonds, minus 2, and it has 4 dots. Let's go ahead and plug that in. 2 minus 4 gives me 0. So the overall formal charge for carbon dioxide is 0. This is 0, this is 0, and this is 0. That's hecka stable because the electrons are distributed evenly. Let's look at the second option, which we said carbon dioxide could be potentially 3 bonds to 1 oxygen and only 1 bond to 1 oxygen. Let's go ahead and fill out the electrons so that it is a complete octet for oxygen. Oxygen has 2 electrons. 1, 2. Let's go ahead and fill out 1, 2, 3, 4, 5, 6. Should have a total of 8. Let's count that. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Let's count this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. There we go. Let's double check for carbon as well too. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Each one of them has 8 electrons. Let's calculate its formal charge. So remember, formal charge formula is the number of valence electrons minus the number of sticks or bonds, however you want to say it, minus the number of dots, which is non-bonding electrons. These electrons aren't in a bond. So let's go ahead, put down dots, and let's put down sticks. And this valence electron value, we can find it on the periodic table. So let's calculate its formal charge. Let's use the same way to notate these. So we'll call this oxygen 1, carbon, and oxygen 2. Oxygen 1, I put the carbon in the middle. Carbon and oxygen 2. Let's label these. Oxygen 2, oxygen 1, and carbon in the middle. Perfect. Let's go ahead and calculate its formal charge. So previously I stated that oxygen 1 has only 6 valence electrons minus how many bonds does oxygen 1 have? Sorry, I'm going to raise this down a bit lower. Let's calculate how many sticks it has. 1 stick. So I'm going to write down 1 stick. Now let's calculate how many dots does it have, or the number of electrons not bonded in a bond. 1, 2, 3, 4, 5, 6. 6. Okay, let's calculate that. That would give us a -1 charge. So on this oxygen, we see a negative charge on it. Okay, let's go ahead and let's take a look at carbon in the middle. Carbon over here has 4 valence electrons minus how many bonds is it connected to? Let's count. 1, 2, 3, 4. So it has 4 bonds and 0 dots, or 0 non-bonding electrons. So let's go ahead and let's put a 0 down below. It gives us a 0 charge on carbon. Let's calculate our last oxygen. Oxygen has 6 valence electrons minus how many bonds does it have? 1, 2, 3. It has 3 bonds. So let's input that. Minus how many dots does it have? 1, 2. It has 2 dots. Calculating that gives me a +1 charge. Let's go ahead and place a +1 charge onto that. As we can see here, that this has a lot of charges on it, making it super reactive, as opposed to this option, which had 0 charges on it. So a chemist would likely place the correct Lewis structure as option 1. Let's go ahead and do another example, and let's practice with ammonium. Ammonium is NH4+. Let's calculate its formal charges by first creating its structure. So nitrogen is connected to 4 hydrogens. Actually, let me just write it as ammonium. And ammonium has 1 nitrogen and 4 oxygen. Nitrogen, let's calculate its formal charge. And then for hydrogen 1, hydrogen 2, hydrogen 3, and hydrogen 4, we don't really have to calculate the hydrogens on it. However, instead, let's calculate only nitrogen. Let's see if it actually has a charge on itself. Using the formal charge formula, formal charge, which is the number of valence electrons minus number of bonds minus number of non-bonding electrons or dots, and this is sticks. Let's go ahead and calculate nitrogen's formal charge. Okay, nitrogen has 5 valence electrons and I can tell from the periodic table, minus how many bonds is it connected to, or how many sticks? 1, 2, 3, 4. It's connected to 4 sticks, and it has 0 non-bonding electrons. It means it has 0 dots. Gives me a total of +1. Nitrogen has a +1 on it, giving me that the overall formal charge of ammonium, which is NH4+. There we go. Now I'm going to allow you to practice it with a couple of examples. Let's go ahead and try option 1, and then option 2, and then option 3. Okay. OH minus, BF3, and HCN. Okay, take a moment and solve this. Okay, let's begin. Remembering the formal charge formula, I'll just simply write valence electrons minus sticks minus dots. Let's go ahead and calculate it. Oxygen is connected to hydrogen. Let's calculate how many electrons it needs to complete an octet. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to fill out 6 electrons. Okay, let's calculate it. Oxygen has 6 valence electrons. It only has 1 stick minus 6 dots. 1, 2, 3, 4, 5, 6. 6 dots gives me with a charge of -1. So oxygen has a charge of -1, which is why we notate it as OH minus. Let's go ahead and do the second example. B is connected to 3 fluorine atoms. Let's go ahead and calculate each of its charge. So borine has 3 valence electrons. It is connected to 3 sticks, and it has 0 non-bonding electrons, giving me a total of 0. Let's go ahead and look at fluorine. Fluorine here, because each of these fluorines are the same, thereby meaning that fluorine is connected to only 1 single bond, I'll just calculate them as all the same. Let's fill out the electrons because fluorine has an incomplete octet. 1, 2, 3, 4, 5, 6, 7, 8. Let's do the same for all of them. It requires 6 more electrons. Perfect. Fluorine on the periodic table is in group 7A. So its valence electrons is 7. Minus how many sticks is it bonded to for boron? Only 1. Minus how many dots or non-bonding electrons is 1, 2, 3, 4, 5, 6. Perfect. Giving me a total of 0. So boron and fluorine and all these fluorines actually, overall have a formal charge of 0. So if it makes it easier for you, I can literally put zeros on all of these to show that there isn't any charge on any of these atoms. Let's go ahead and do the last one. H is connected to carbon with a triple bond on nitrogen. Let's double check and make sure that each one of these atoms have a complete octet. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. It's perfect. It has a complete octet. Nitrogen, 1, 2, 3, 4, 5, 6. Okay, let's add 2 electrons to make it 7, 8. Carbon, let's calculate its formal charge, which would be a 4 minus how many sticks is it bonded to? Or how many bonds is it connected to? 1, 1, 2, 3, 4. It has 4 sticks. Minus how many electrons does it have, or how many dots? It has 0, giving oxygen a formal charge of 0. Let's go ahead and calculate nitrogen. It is in column 5A. So I'm going to put down a 5. How many sticks does it have? 1, 2, 3. It has 3 sticks. Minus how many electrons does it have? Each non-bonding electrons. Non-bonding, that it's not in a bond, it has 2. So let's put down 2. Overall, nitrogen has a formal charge of 0. I hope this was helpful in understanding formal charges. And if you need help, there's lots of information on the internet as well as the answer to. And that's how we calculate a formal charge.